All right, so far, guys, we know 3 rules for taking derivative. What are those 3 rules? Power rule, quotient rule, and product rule. All right, so our last rule, guys, is the chain rule. The chain rule has to deal when you have a function within a function. Okay? It's when you have a function within a function. So basically, it's kind of like there are 2 functions going on, except that they're not being multiplied. One is actually inside of another. Let me give you an example of what that looks like. If I wrote this right here. Okay? If I wrote 3x plus 2 squared, how many functions are there? What are they? 3x plus 2 is a function, right? And that is inside what? X. You have to imagine that this is an x. So there's 2 functions. The outside function is x squared. The inside function is 3x plus 2. Does everybody see that? Okay, what if I wrote something like this? Sine of x squared. So which one's inside, which one's outside? Sine of x is on the outside, and x squared is on the inside. Does everybody see that? Okay? You have to be able to see that there are 2 functions there. Okay? So here we go. So far we've taken a lot of derivatives. However, they all look kind of something like this. Very simple, very easy. Like for instance, this one right here. What did I have to do to it? So I changed it to z to the 1/2, and when I took the derivative, it became what? 1/2 z to the negative 1/2, right? You don't have to, I mean, this is just kind of review. What about t to the 50? 50t to the 49. Ooh, what about tangent of x? Do we have that somewhere? You should. You wrote it down. I told you memorize it. It's just secant squared. So the derivative of tangent is just secant squared. Right? Okay? And that's just a rule. Okay? We haven't seen this before. So this is like e to the x power, right? Y'all have seen that before? Does anybody know what that's called? It's an exponential function. So e to the, in this case, w, its derivative is itself. So those are the easiest. Anytime I ask you to derive e to the x power, your answer is e to the x power. It's itself. Always. Okay? Good question. So he said, yeah, but then what happens when you add something to it? Like, what if it was e to the 2x? This is a chain rule because there is a function 2x inside of another function e to the x. Okay? So that's what I'm going to teach you today. Okay? Pretty simple. And then here's another one. Does anybody know what this is called? ln. Yeah, what is it called? It's a natural log. Right? It's a natural log. So natural log of x, this is a natural logarithm function. Its derivative, again, it's just one of those rules that I need you to just memorize, is 1 over x. Okay? So, we've already memorized these. I'm giving you 2 new ones today. So, the derivative of any exponential is essentially itself, right? E to the x is just e to the x. Any derivative of a natural logarithm, like natural log of x, is just 1 over x. Okay, but obviously, because I'm mean, I'm going to give you something that looks like this down here. Well, what is the natural log of blah, blah, blah? What do you notice? There's 2 functions, a function within a function. That is why I'm teaching you the chain rule. Got it? Okay, so see these down here? These are versions of these, right? Of the top, but obviously they're more complex. But it's okay. You don't have to freak out. I'm going to teach you the chain rule. Any questions? All right, let's get into it. forgot to clear my stuff going on here, so give me a second. No, that's why I paused it. Is it? Ooh, that'll be funny. I thought I paused it. Ready? There we go. All right, so guys, it says here in algebra you learn composition, right? Compositions, your composite functions of two functions, f of x and g of x, which is written as symbolically as f of g of x. We also called these. Anybody remember? We also called them the Fogg and Goff. Do y'all remember those? Okay. Do you remember? You don't remember them? You never heard of Fogg and Goff? All it literally means is you read them backwards. This means g composite f, or f composite g rather, and this just means function g was stuck into f. All right. So these are just some quick examples. If I told you, look, if f of x is x to the 7th power, and g of x is 3x to the 5th, then f of g of x, g into f, notice that the one g is literally inside of f, right? It would look like this. 3x squared plus 5 to the 7th power. Does everybody see that? Okay? If I were to give you sine of x and x cubed, and I asked you for f of g of x, then it would look like this, sine of x cubed. And then finally, if I give you x cubed and cosine, then it would look like this, cosine of x to the 3rd power. We write this as, so this is, I want y'all to kind of pay attention to this last one. So if I asked you to put cosine or any kind of trig function into an exponent like this, so technically it should look like this, right? But this is how you'll see it. So when y'all see these, this means cosine of x to the 3rd power. Okay? Or cosine, mostly you'll see it squared. Okay? So here is my chain rule. This is the important part. So this is the actual rule. Suppose we have two functions, f of x and g of x, and they are both differentiable. If we define f of x as the composite, then the derivative is this, f prime original g times g prime. Okay? So this is the important. I need you to copy it down. So in words, can y'all tell me what this is in words? Like, yeah. No, I can read it. What is it? Like, describe it to. What would you do? Good. Not derivative of the inside. So it's the derivative of the outside, the original inside, times the derivative of the inside. Does everybody see how that works? So it's the derivative of the outside with the original inside times the derivative of the inside. So this is where most people will make their mistake. You have to leave the original second function in when you take the derivative of the outside, okay? So I'm going to give you some quick, like a quick little example, okay, just to kind of get through it. Here's my function. Here's my function. Yeah, you can write this down. So, do y'all notice that there are two functions here? What's the outside function? It's 2x to the 4th power. This is a large x. Does everybody see that? So the outside is 2x to the 4th power. Okay? This parentheses. So it's 2x to the 4th power. That's the outside. Got it? So that's my f. That's my f. So then, obviously, my inside function, my g, is the what? 3x plus 4. Okay? So, when you're learning, guys, this is a good technique to actually write them out. This is my outside, and of course, this is my inside. So then, when I take the derivative, the rule says to do what? Derivative of the outside, leave the inside, times the derivative of the inside. Okay, so what is the derivative of the outside? 8x, so it would be 8x cubed. Except I have to leave my x, remember, is the inside. So it's 8, 3, wow, come on. 3, come on. 3, come on. No, there's no. No, it doesn't. 3x, there you go, plus 4. And then it's times the derivative of the inside, which is just 3. You don't really have to, because look what we're going to do. So this is f prime of g times g prime of x. Does everybody see that? Okay? And then what you should do at this point is simplify. Now, I have students all the time that want to say, oh, so then I can just distribute this 3 to the 3x plus 4? Why not? It's cubed. If you were going to do that, if you want to distribute according to PEMDAS, shouldn't you deal with the exponent before you multiply? So, do you want to sit here and cube this out? No. I don't. So then the only thing I can really do to simplify is multiply the two fronts. So this really just boils down to 24 3x plus 4 to the third power. That's as simple as you need it to be. If you really, really wanted to, be my guest, cube this out and then distribute that 24. I don't require it, okay? You really shouldn't. You're just it's wasting your time, really. This is as good as it gets. That's what I would. You could probably even leave it like that. Oh crap! Be on top of your game. Okay, so let's get started. So let's see if you can understand using the chain rule to differentiate this problem right here. Okay, so R of z equals the square root of 5z minus 8. Can I do something to that function first? So what would it be? Okay, 5z minus 8 to the 1/2 power. So what is my outside function? X to the 1/2. And then what's my inside? The 5z minus 8, right? Or zx, whatever, same thing. So does everybody see that this is two functions? X to the 1/2 and 5z minus 8, right? So then when I actually take the derivative, what's going to happen? 1/2, leave the inside, 5z minus 8 to the negative 1/2 times 5. Can I simplify this a little bit? You can do what? Multiply the 5.5, which gives me 5/2, 5z minus 8 to the negative 1/2, and then of course what? I don't want this negative, and I have to change it back to a radical. So can I do that in one step? Where is this going to go? Okay, so right now, does everybody realize that this is technically at the top, right? This is it's technically over 1. So when I send it to the bottom, there's something already there. What? The 2, right? So this is going to be what? 5 over 2 square root of 5z minus 8. Okay? Got it? Easy, right? Too easy? Make it harder? Okay. We good? Let's try another one. Let's try this one. Excuse me. Okay, so here's my function. F of x equals sine of 3x squared plus x. What's my outside function? sine of x, and then of course my inside is 3x squared plus x. So when I take the derivative, I do the derivative of the outside, which is cosine. Derivative of sine is cosine, bless you, cosine of my original, so 3x squared plus x, and then it's times 6x plus 1. So technically, notice I'm putting this in parentheses because it is a binomial, right? It's not just one thing. Could I simplify this? Actually, in this case, not really. Yeah, so the only thing you can really do is move it to the front. And why would I want to move it to the front? Simply because if I left it like this, most people would think it's the cosine of all of it, right? But it's only the cosine of this. So the only thing I would do is 6x plus 1 cosine of 3x squared plus x. Okay? You really can't do anything with it, so just don't worry about it. That's it. Do you have to? Absolutely not. Have to is not the right word. However, it's just less confusing if you put it up front. All right, next one. Yeah, right there. So I have 2t cubed plus cosine of t times, or I'm sorry, to the 50th power. Okay? 2t cubed plus cosine of t to the 50th power. What's my outside? X to the 50, and then my inside is the 2t cubed plus cosine of t, right? So notice now my inside is getting a little bit more complex. It's actually almost two functions, right? But it's still just the inside. So when I take this derivative, what do you got? 50, and then blah, 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 2t cubed plus cosine of t to the 49th power times 6t squared minus sine of t. So, good question. Well, how do you think I should simplify this one? So this is going to go to this, right? These two have to come together to basically distribute it and make it one. So it's going to be what? 300 t squared minus 50 sine of t times 2t cubed plus cosine of t to the 49th power. And again, this is one of those ones where it's like, do I have to multiply it out? Do you think I really want you standing here to do this 49 times? Yes, I do. Start now. I'm joking. 50 times 6, right? Got it? So I basically just distributed the 50 to this. Yeah. Because remember, I can't distribute to this because of the exponent. I would have to do this 49 times in order for me to distribute to this. Does that make sense? Yes, eventually, but you don't have to. Okay, you don't have to. Like I said, I don't want you. You don't have the time, nor the. I don't know. No. Let's do an extra credit. Let's do an extra credit project. Multiply this out 49 times. It would get ridiculous. Yeah, it would get ridiculous. So you would do two at a time. You would have to do only two at a time. So you'd FOIL the first two, and then you'd have a trinomial times the original binomial, and then you'd have a 4-term times the 2, and then a fifth, all the way for 49 times. So eventually you yeah, it would be ridiculous. Yeah. Yeah, no. You pass the class automatically when you pass the tests. Deal? What? We have a test? Yes, we do. I wish they honestly offered a calculus like a honors, not AP, or maybe even dual credit. Squared. All right, so here we go. We have h of w. It's e to the w to the fourth power minus 3w squared plus 9. So what's my outside function? E to the x, right? It has to be. It's not just e. It's e to the x power. Okay, so it's e to the x power. Um, and you actually have to understand: is there a difference, guys, between this? This is kind of side note, and this? No. Why not? Remember, e is just a what? E is just a constant. E is like pi. Pi is 3.1. E is 2 point what 718 or something like that, right? So remember, this is just so. If I ever give you a function that looks like this, what's the derivative of this? Itself. Okay. So the rule is for any exponential function, not just e to the x. It's any exponential function. Okay. So keep that in mind because you will see that. So you will see that. All right. So here we go. My outside function is e to the x, right? And then my inside is all of this. So tell me, what do you think the derivative would be? So it's itself, right? So e to the w to the fourth minus 3w squared plus 9. But then it's times 4w cubed minus 6w. And again, the only thing I can write this up front. Is it going to make a difference? No. Could I multiply? Can I distribute this e? No, because this is being taken to an exponent, okay? So it's the same as the others. You can't really mess with it, so that's basically it. Simple as that. Okay? So, the natural logs get fun. Natural logs get fun. So I have natural log of x to the negative 4 plus x to the fourth. Natural log of x to the negative fourth plus x to the fourth. What's my outside function? Natural log of x. And then the inside is x to the negative 4 plus x to the fourth, right? Okay, so how's this going to work? So it's 1 over, what's the derivative of the outside? 1 over x times the original, x to the negative 4 plus x to the fourth, times negative 4x to the negative 5 plus 4x cubed. Okay, so this gets fun only because of the simplification that has to go on here. So, you realize, technically, this is all over 1, and this is all over 1, right? So couldn't I write this as this is really negative, wow. This is x to the negative 4, come on. Plus x to the fourth, negative 4x to the negative fifth, plus 4x to the third. All of that technically over x. I'm not rewriting that. Okay? Could I simplify this even more? How? I would have to actually FOIL this out. This one I can simplify. So this one's going to be, so FOIL this out for me. What do I get when I FOIL this out? Negative 4x to the negative 9. Plus 4x to the negative 1. negative 4x to the negative 1 plus 4x to the 7. Again, all of that's still over x. You notice something? Those are going to cancel. So really this is 4x to the negative 9 plus 4x to the 7 over, okay, over x. Y'all notice something. See this x, do they all have an x that I can cancel? Yeah. So if I take away 1x from everything, I'm left with negative 4x to the negative 10. Because remember, what do you do to the exponents? Technically, you're subtracting them, right? And then plus 4x to the 6th. Is that my final answer? I have one issue. That's the only thing I got to fix. So this would be a negative 4 over x to the 10th plus 4x to the 6th. See, that's why I said the natural logs are fun. This is so natural log is called natural log for a reason. It actually happens mostly in nature. So logs were invented because they were unique ways to write very, very large numbers. Very large numbers. Like for instance, insects. When insects population grows, it grows at an exponential rate, right? They don't have one kid like humans do, for the most part. They have hundreds of kids. So it's not like you're gonna sit there and count. So they created these equations. They said natural log. They all follow this pattern eventually, right? This on a very high scale follow this pattern. So when you find the derivative of a natural, aren't you finding the rate of change? So technically, you could find how fast a population of an insect is growing. So like the Zika virus thing, that's guaranteed they use something like this. They had to figure out how fast are these mosquitoes multiplying to figure out how far, you know how they, like in Miami, how they have like a certain range, like try not to go to this area. So that's what they use. They use stuff like this to figure out, okay, it's growing this fast at this rate, so they try to stay ahead of it. So there's some real world for you. Any questions with chain rule? Yes, ma'am. This one? This, yeah. Mm-hmm. Uh-huh. Because this is over 1. Like, they're two fractions. You're saying why isn't it 1 over this? Because it's multiplication, right? Like it's 1 over, I'm sorry, it's 1 of x times this. So if it's multiplication, this is technically over 1, and it would go on top. Right? Any other questions? Oh, dude, I thought that was the last examples. 2 more. We got 10 minutes, that's fine. Or we have more than 10 minutes. I want it to be done by 10. Secant, secant, secant. All right, what's my outside function? Secant of x, and then the inside, of course, is 1 minus 5x. What is the derivative of secant of x? It's secant times tangent. It's secant x times tangent. So, if f of x, this is just a side note, is equal to secant of x, then its derivative is secant of x times tangent of x. So this one's interesting because I get technically two more functions pop up, right? So the derivative of this is going to be what? What do you think? Secant of 1 minus 5x tangent times 1 minus 5x. And that's just the derivative of the outside. And then times what? Negative 5. And then technically, the only thing I can do to simplify is what? Put the negative 5 up front. So it'd be a negative 5 secant 1 minus 5x times tangent 1 minus 5x. Okay, now this is the last one. So I have cosine of the fourth power of t plus cosine of t to the fourth power. So do y'all notice something? This is actually two chain rules. It looks like I like two chain, right? So, do y'all know this? Do y'all recognize this? Do y'all recognize? Can I rewrite this to make this kind of more simple in my mind? Because remember, what did I tell you at the beginning? This. So it's cosine of t to the fourth power, technically, right? You got to think of it that way. So we don't have to do this all the time, but because we're learning, when you see cosine of 4 of cosine to the fourth power of t, technically it means cosine of t to the fourth power, right? And that's going to help me with my chain rule. And then over here, there's nothing I can rewrite. So it's really just cosine of t to the fourth. So I'm going to end up doing two different chain rules. One for the first part, one for the second part. So for the first part, what's it going to be? 4 cosine of t cubed times negative sine of t. Is everybody with me on that one? Right? So it's the derivative of the outside, so the 4 comes minus 3 of the original, times the derivative of the inside, which is negative sine. You with me? And then, now on this one, what's my outside function? And what's my inside function? T to the fourth. So this one's going to be, okay, the derivative of the outside, negative sine of the original, t to the fourth, times 4t cubed. Okay, now simplification in this case is really not that much, but I can just put things up front and like I needed to. So for instance, this would be a negative 4 sine of t cosine of t to the third power minus 4t cubed sine of t to the fourth power. Could I combine these two signs? No. This one's sine of t, this one's sine of t to the fourth. Two different things, okay? Alright, so now you have all 4 rules. Technically, you can find the derivative of anything now. Of anything. I say technically, yeah. Okay? So, technically you should be able to find the derivative. I think you have power rule, you have product rule, you have quotient rule, you have the chain rule. No function should be able to be written to where you can't find the derivative. Alright? And if it is, odds are we can change it to where I can find the derivative. Okay? Some new rules out of this, some new memorizations was, what is the derivative of an exponential? Itself. Okay? Derivative of an exponential is itself. And what is the derivative of natural log? 1 over x. Okay? So you have everything you need. No trash.